Standard form, significant figures and rounding, AQA GCSE Chemistry. Standard form is a way of representing very large or very small numbers. The format is that a number between 1 and 10 is multiplied by 10 raised to a whole number power. So let's look at some examples. 3,200, well, in standard form, you will see it written as 3.2 times 10 to the 3. How is that achieved? Well, we've got our decimal place here, and we're moving it once, twice, 3 times to the left. So 3.2 times 10 to the 3. 3.2 times 1,000. Let's look at another example, 0.00045 in standard form. Well, that is 4.5 times 10 to the minus 4. What we've done here is we've moved the decimal place once, twice, 3 times, 4 times to the right. So 4.5 times 10 to the minus 4, in other words, 4.5 divided by 10,000. What would 8.9 times 10 to the 6 be in ordinary form? Pause and write out the numerical answer. Okay, so I'm going to reveal 8,9,0,0,0,0. So we've moved the decimal place to the right 6 times. So 8.9 times 10 to the 6 is 8,900,000. We've moved the decimal place 6 times to the right and inserted obviously zeros as space fillers. What about 6.79 times 10 to the minus 5? What is that in ordinary form? Well, if you've written your answer, I'm going to reveal, otherwise pause. Okay, so that's 0.123400679. So I've moved the decimal place 5 times to the left. Okay, I've divided by 10 5 times. Let's look at significant figures. The result of a calculation using measured quantities cannot be more certain than the least certain measurement used in the calculation. So this is relating to scientific data. The final result should be the same number of significant figures as the data with the smallest number of significant figures. So this is relevant to a calculation in which you have different sources of data with different degrees of certainty. But we need to identify in any number the significant figures. There are a few rules. Any number that isn't 0 is significant. Any 0 that is between two numbers is significant. We refer to that, or I will, as a trapped 0. Any 0 that is before all the numbers is not significant. But any 0 that is after all of the numbers is significant if the number includes a decimal place. In the absence of a decimal place, those zeros after all of the numbers is not significant. Here are 3 problems. How many significant figures in each example? A volume of gas measured to be 120 centimeters cubed. A student measured 0.0206 grams of copper oxide. A student recorded a mass of 0.850 in a data table. Have a look at the rules. How many significant figures in each example? Pause Come back to check and correct when you are ready. Okay, so a volume of gas measured to be 120 centimeters cubed. Well, that's only got two significant figures. There is no decimal place, so the 0 after the numbers is not significant. So two significant figures, the 1 and the 2, the non-zero figures. A student measured 0.0206. Well, there are three significant figures. The 2 is significant, the 6 is obviously significant, and the trapped 0 is significant. So three significant figures. Finally, a student recorded a mass of 0.850. Well, there is a decimal point, so there are three significant figures. We're going to count the 8, the 5, and the 0 as significant. Rounding. Round 5.5648 to three significant figures. Well, the first step is to identify the three most significant figures. Well, that's going to be, those are the figures furthest to the left, so it's 5.56. In blue, those are the three most significant figures. They are the three furthest to the left. Then look at the fourth significant figure. If this number is above 5, is 5 or above, I should say, then round up the third figure. If this number is 4 or less, do not round up. So we're looking at the fourth significant figure because we are rounding to three significant figures. So we look at the fourth significant figure. It is a 4, so we do not round up the third significant figure. Hence, rounding 5.5648 to three significant figures is 5.56. So when would we round? Here is the bugbear of chemistry teachers. You only round at the very end of a calculation. Rounding after each step in a calculation will affect the end value. And that effect has even got a name. It's called a rounding error. So please don't do that for your own